So you have to give reason in the following cases. So if you have this molecule and you treat with C2H5OH, that is aqueous, the final solution that is formed is acidic solution. So you have a acidic solution. But if you treat, while you treat this molecule in the presence of C2H5OH aqueous, solution is not acidic, it's a neutral solution. Why this is so? So you have to explain the acidity of the first solution and neutrality of the second solution. That is your task. And you see C2H5 is not a strong nucleophile, this is a neutral nucleophile, neutral molecule, so it will not be a strong nucleophile, this is a weak nucleophile. So when any reaction is possible, it will happen through SN1 mechanism, that is carbocation will be formed. Okay, so let us see in the first case you have. So you have this molecule, let me write CCH3, and then here also you have CH3 and then bromine. Now if you release this Br, so you will get a carbocation. And now this carbocation is basically resonance stabilized by the benzene ring, and inductive effect CH3 will also show inductive. So this carbocation is a stable carbocation. In the next step C2H5 will attack here and H will leave. So finally the product will have, so I will have CH3 and here also CH3, and then I will have OC2H5, that is OET. Now what is lost? So one molecule of bromine that is lost from here and one H plus that is lost from OET. So I will also have a product HBr. So you see, in this reaction I am getting a product HBr that is acidic in nature, so solution becomes acidic. Now in this case mechanism that is followed is SN1. Why the mechanism is SN1? Because carbocation is formed, this carbocation is resonance stabilized, and that's why this reaction takes place. But in the next case if you see, and even this carbon is sp3 hybridized, but if you see the next case, you will have Br here and CH3, this side you have a CH3 group and one CH3 this side. Now if you treat this compound with C2H5OH, in this case this carbon is sp2 hybridized. So on sp2 hybridized carbon there is nothing like carbocation that is formed. So no SN1, no SN2 reaction takes place in this case. So it does not react with C2H5. So no carbocation is formed. So no SN1, no SN2. We have discussed. There are three regions. So this ring is slightly, this bond is slightly double bond character. This is sp2 hybridized. Nucleophilic substitution does not take place in the benzene ring because C2H5OH has only one option. It can act as a nucleophile, and of course this is not a strong nucleophile. So benzene ring nucleophilic substitution happens only if this nucleophile is strong, as well as benzene ring should be deactivated, but benzene ring in this case not deactivated. So no SN1, no SN2, no nucleophilic substitution reaction, because benzene ring is not deactivated. So now I can say benzene ring is not deactivated. So this is the why nucleophile cannot attack in this case. Now let us discuss the next reaction. So if does not happen any reaction, so solution remain as it is, that is neutral. If it was initially neutral, so it will remain electrically neutral, not electrically neutral, acidically neutral. Okay, let us discuss this problem. So in the first case fluorine gets liberated, but in the second case fluorine does not get liberated. You have to explain why this is so. Let us take 30 seconds time. So what should be the reason? Now you see, in this case, first case, you have a NO2 group that is attached to the para position, and in this case you does not have any NO2 group that is directly attached to the ring. Now see, nucleophilic aromatic substitution takes place now. Na plus OH minus is acting as a nucleophile. So nucleophilic aromatic substitution takes place in the benzene ring is only if there are some deactivator group like NO2 is attached in the ring at ortho or para position. So this is ortho position and this is para position. So it does not have any deactivating group or ortho position, but we have a deactivating group at para position in this case. So this ring is deactivated, and that's why. So what is happening? So you have NO2 here, and here you have CH3. So this ring is basically deactivated ring. And that's why nucleophilic aromatic substitution takes place. So OH minus comes, it attacks there, and then fluorine goes. Are you getting or not? So what is happening? OH minus with one lone pair. So this attacks here, and this fluorine goes out. So this we have discussed. Are you getting or not? Now in the next case, you does not have any NO2 group that is attached in the benzene. So this ring is not deactivated, so no nucleophilic aromatic substitution. So in this case you can say nucleophilic aromatic substitution takes place. In this case, nucleophilic aromatic substitution takes place. Are you getting or not? But if you have something like this case, no nucleophilic substitution. So this ring is not deactivated ring, CH3NO2. The ring is not deactivated in this case. Are you getting? So no nucleophilic substitution, not a deactivated ring. So in this case, not a deactivated ring. Are you getting or not? So these questions are asked in JEE. Basically, they ask you the fundamental concept. Did you remember or not how the SN1 and SN2 reactions takes place? While nucleophilic aromatic substitution takes place. If you remember these reactions, it is easy to answer these questions. Let us discuss the next problem.